Okay, we're going to start talking about the scientific application of data science by a really basic mathematical concept called a system of equations, which you're probably familiar with from high school algebra. You can see here that I've got a basic system set up just to refresh your memory. It's made up of two equations, equation 1 and equation 2. And if I took these two equations and I rearranged them and I plotted them over here on this plot where x is on the x-axis and y is on the y-axis, I would have two lines that look something like this, roughly, right? They have some sort of intercept, and then they have an intersection here, and that intersection is the point at which both of these equations are true. And so if we're going to solve this systems of equations, we want to find the value for x and y at which both of the lines intersect on the graph and at which both of the equations are satisfied, meaning they're both true. So if I wanted to do this when I was in high school, I would use this concept of substitution, right? So I could take the first equation, and let's say I rearrange it, and I say x is equal to 5 minus x is equal to 5 minus 2y. And then I can take this value for x here, and I can simply just plug it into this equation here, right? So then I could have this equation, the second equation, equation 2 of 1 and 2, only represented in terms of one variable, y. Then that would look like 3 times 5 minus 2y plus 4y is equal to 7, which if I carry these terms through, 15 minus 2y, or I'm sorry, 15 minus 6y plus 4y is equal to 7. Appreciate your understanding of my handwriting here. 5 minus 2y is equal to 7. Then I can rearrange this and say 2y, negative 2y is equal to negative 8. Divide both sides by negative 2, y is equal to 4. All right, and then if I take this y is equal to 4 and I plug it back in up here, then I can say x is equal to 8, which is 4 times 2. X plus 8 is equal to 5. X plus 8 is equal to 5, meaning that x is equal to negative 3. All right, really simple equation, really simple solving. And what we're going to do now is say, if this was much bigger, it would be really difficult to solve, right? So if I had like 100 variables instead of just 2, how do we go about solving these things efficiently? And we'll see here in the next couple of videos that if we recast this problem into a matrix problem, we can take advantage of the scientific libraries in Python to solve these types of systems of equations, which are really closely related to other problems, very efficiently. All right, look forward to seeing you in the next video.